Hello, how are you doing? Welcome to mathematics lesson. In our today's lesson, we shall look at direct proportions. Before we continue, let's start with a note. Very important to note on this topic, direct proportions. If we have two variables, P and Q, where an increase in one leads to an increase in another, they are said to be directly proportional. If an increase in one leads to an increase in another, or if a decrease in one leads to a decrease in another, or in other words, if they increase at the same rate, or if they decrease at the same rate, they are said to be directly proportional. We say P varies directly as Q. The direct relationship between these two variables P and Q is denoted with this symbol. We read as P is directly proportional to Q. This relationship may be written as an equation. When you want to write this proportionality relationship here as an equation, you introduce a constant. This K is a constant here. P equals, instead of the symbol, I'm putting equal signs, then introducing a constant K. P equals KQ. If y is directly proportional to x, if y is directly proportional to x, then a constant k can be found such that y equals kx. In other words, if you introduce a constant here, it can be found. You can calculate it depending on what you're given, as we shall see. Let's look at an example one here to digest what I've been saying. Given that A is directly proportional to B and A equals 12 when B equals 4, find the relationship between A and B as an equation. Find A when B equals 9. Find B when A equals 12. Let's quickly see how we can solve the question as part of the solution. They are saying A is directly proportional to B. Therefore, if I introduce a constant there, A is equal to KB. If you introduce a constant, you leave the symbol, then you put in equal signs. A equals KB. Or someone can write it as A out of B equals K. Here simply, it's like you're dividing by B to remain with K this side. And K is a constant. Then question A, they told us that when they want a relationship between A and B as an equation, but in the question says A equals 12 when B equals 4. Let's use that. A equals 12 when B equals 4. If I substitute in this equation, A is 12, B is 4, I'll have 12 out of 4 equals K. And finally, I get K as 3. The value of K is 3. We found this constant. Thus, A out of B equals 3. Or someone can say A equals 3B. B has multiplied by B both sides. Now, that is our relationship as an equation. That is a relationship between A and B. A equals 3B. Let's see how we can attempt question B. Question B, they want us to find, we can revisit the question. They want us to find A when B equals 9. They want us to find A when B equals 9. If B equals 9, and we've already got the relationship as A equals 3B, what we need to do there, we just substitute. Where there is B, I'll put 9, and I get the value of A. A will be equal to 3 times 9, which is 27. Then question C, They want us to find B when A is 32. They want us to find B when A is 32. Let's see, as part of solution, we have A at 32 and we have the relationship A equals 3B. We just substitute 32 equals 3B. But they want the value of B, not the value of 3B. What we do, we divide both sides by 3 and we end up getting 10B as 10 and 2/3. Or you can write it as decimal points, no problem. That was our example 1. Let's see example 2 here. Given that y varies directly as a square of x and y equals 12 when x is 2, find y when x is 5, find x when y is 15. Let's see how we can attempt that. Now, like here, they have not asked us to find the relationship, but it will be wise, you'll be wise to first find that relationship. Let's try and see. We have y varies directly as x squared. We introduce in equal signs and we bring in our constant. Y equals kx squared, where x is a constant there. Then in the question, when y is 12, x is 2. Let's substitute to our equation here and we see where there is y, we put 12 and x is 2. I have 4 here, that is 2 squared. 2 squared is 4. We have 12 equals 4k. Dividing both sides by 4, you end up getting k at 3. So y equals 3x squared. That is our relationship. Now we can go ahead to answer question A. Find y when x is 5. If x is 5 and we have the relationship that y equals 3x squared, what we need to do is to substitute the value of x. We have y equals 3 times 5 squared. If we simplify, we shall have 5 squared is 25. We have y as 3 times 25, which is 75. Then B, they want us to find x when y is 15. We are given y, we want x. And we have the relationship here as y equals 3x squared. What we need to do is just substituting. 15 will be equal to 3x squared. But we want x. We want the value of x, not the value of x squared. Here to get x, we first make x squared the subject there. We divide by 3 both sides. We end up getting 15 out of 3 equals 3x out of 5 out of 3. We get 5 equals x squared. But we don't want x squared, we want x alone. What do? We take the square root both sides and we end up getting x please, there is that one should be x equals the plus or minus root. Let me get ink and correct here. X will be the plus or minus root of 5. Remember, when you take the square root of a number, you either get a negative or a positive answer. That is our solution. Let's continue and see. Example 3. Let me give you ample examples. Let's attempt example 3 here. Example 3 says, in the following table, B is directly proportional to A. Find an equation connecting B and A. That is the table. In this table, B is directly proportional to A. Find an equation connecting B and A. Then question B, find the missing numbers in the table. They are saying B is directly proportional to A. You can see when A is 1, B is 7. When B is 2, when A is 2, B is 14. You can see this one has doubled and this one has doubled. Then let's see how we can attempt. Find an equation connecting B and A. As part of solution, uh, the question says B is directly proportional to A. I can first make it an equation there, then I find the value of K. From the table here, that is our table here. From the table, when A is 1, B is 7. We can use that to get the value of the constant there. When A is 1, B is 7. If I substitute in this equation here B equals Ka, I will have K as 7. That is the value of K. Hence, the relationship is B equals 7A. After getting that, that is the relationship. This is the equation connecting B and A on that table. Now, the question here, find an equation connecting B and A. We've attempted it. We've attempted the equation. That is the equation connecting B and A. Then question B, they want us to find the missing numbers. They want the number here, they want the number here. When A is 3, and when B is 49, and when A is 10. Let's start with when A equals 3. When A equals 3, and we've already got the relationship, the equation connecting the two. We substitute A, B will be 7 times 3. We are substituting in this equation here, the relationship here. Then B is 21 there. Then if B is 49, we are now here. We are on this table here. Now we have B, we want the value of A. If B is 49, then and we have the equation connecting that two, we just substitute B will be 49 equals 7A. We divide both sides by 7 and we get A as 7. Meaning when B is 49, A is 7. Then another question in the table, because they want us to find all the unknowns. When A is 10, what will be the value of B? You can pause and first find that value before we continue. B will be 7 times 10, which is 70. As usual, I have to leave you with the questions. They are just two. Please pause the video. Feel free to pause the video and you try out. Question 1, if the cost of books varies directly as the number bought, and if 5 books cost 2,500 shillings, find the cost of 9 books. Then question 2, traveling at a constant speed, the distance traveled by a car is directly proportional to the time taken. If 190 kilometers is traveled in 4 hours, find, question A, the distance traveled in 10 hours. Question B, the time taken to travel 285 kilometers. Thanks for watching. Subscribe to my channel to keep getting notified of other videos such that you don't miss any. Thanks for watching.